Okay, thank you everyone for coming to my talk, and I hope you enjoy it. So this will be a talk about push notification systems and components of this system actually, not many systems, but what we had before and what we have right now. My name is Aleksei Magusev. I'm working for the football company. Previous name on, or still called like Football Addicts, you may know. And my handle on internet is LexMag. But before we go in, my main goal besides building push notification systems is, of course, take over Elixir and then make ML style syntax. But I fail horribly, as you see. But at least I can put style in Elixir. And this link actual style guide that we follow, trying to follow right now. And also you may know me by this wonderful warning. I guess all Elixir developers know how wonderful it is. And especially when it comes from dependencies, but yes, it's part of our life. It's all right. You can blame me. Yeah, that's all right. Sometimes I'm adding features to Elixir. This is some that I like the most. But what I will talk about, this is about push system for the football application for mobile devices. And these screenshots show what this feature actually looks like for end user. So you can subscribe for push notification events like match start, goal, all live events that may happen in a game. And then you receive this notification, and when you open, you have this rich format which show you lineup for recently played game this Saturday. Probably you who like football know this. And this football, saying football, I mean not American TV show, but football that TV show in Europe. Some facts about this system, which is important to understand why we needed new system. That it has several platforms. We do billion notifications more than this in a month, and many million users subscribe to events. And also we have issue because many millions stored in database. But what makes this need for new push notification system in overall only because all these push notifications are very time sensitive. Who wants a goal notification 1 minute after a goal in real life? I guess nobody, because it's just junk, it's unnecessary. From high perspective view of a system, basic push notification system divided by two parts. And this is basically divided also by time. You manage storage of subscriptions in one moment when people subscribe and unsubscribe from push notifications, and you manage or actually push notifications when some event happens. And you use storage as a heart of this system. And before going forward, how this subscription looks like. This oversimplified version, but still shows what we store. You have device token. It's needed to identify who will receive this notification. And also you have subject. And this part important because actually notifications can overlap. As you see, all these notifications have same token, same language, all properties the same except subject. We already know by using this format that someone from Sweden who speaks English wants to receive notification for a team and tournament. But there is one issue with this storaging, with these records, that they overlap in a matter that if this team plays in a tournament and match happen, so you will receive two notifications, which should not be, we must not to allow this. Why you need two notifications for a match? And we need somehow to resolve these overlaps. That's why this how steps when we send notifications looks like. At first, this notifier on the right side, it receives match event. Then we fetch all available notifications for this event. And this is important that we need to receive and fetch from database all possible events, because then, only then, when we have everything on hands, we can filter out duplicates and push this forward. Of course, build translated messages. This is another step. As you saw, we have language, because people like their own language to see on notifications, easy to understand. Like, this is feature. But you have an issue when you do this that way. This is very straightforward way. When you fetch everything to deduplicate on a client side or worker side, and this has started to be an issue for us. If you store millions of thousands of millions subscriptions, and you fetch even 2 million subscriptions, it can take minutes to fetch these subscribers. And basically, you're stuck in this step. You don't even start sending notifications to the user. You wait minutes just to get what tokens want this notification. And this has several issues. First of all, as I said, it's a blocking. You're not receiving notification at all while we're fetching these subscriptions. And we have normalized data, and this is why it's slow. And everything's sequential. After we fetched, deduplicated everything, it still goes step by step with translation, with all enhancements of message that we will send. And another issue was that you can't really scale such system because it was monolithical design, and even if you add one more, it won't happen because it lives inside one component. And that means that time came to rewrite, and this tractor, it's basically rewrite. When you feel that you have so many efforts to add new features, probably it's time. Yeah, it took quite a long time for us, because if you imagine like 1.5 years for a new system, it's a lot. Even if someone will tell me, like, I worked on something 1.5 years, like, I don't know, it's too long. Yeah, but this is what it actually, because for reasons, and these reasons, we had only 2-person team. Yeah, you have 2-person, you can't expect do this faster. And these 2-person still did a lot of stuff in other systems and components of our backend. And of course, we did a really good storage research and prototyping. How not to end up in this system, similar situation in next few years. And extra problems. We have no metrics. At this stage, we had no metrics, and this means how you can improve something that you can't measure. That's why we also built a system for metrics collection. And at the same time, we migrated to Amazon Web Services. And still, it took some time. This same representation, but with some really important events that happened during this rewrite. Yeah, and speaking about storage research and system prototyping, it took quite a long time because we wanted from the first issue with our old system, because users was quite angry, typical users, and competitors was quite happy. So we should build something that don't let us be in the same situation in the next years. And we spent a lot of time. And this quote that I try to keep always in my mind when I thinking about something big, that you probably need to spend more time on tryouts. And our choice is Cassandra. And this was a bit of a surprise for me, because at first I didn't expect anything like what will be the best, but Cassandra fits wonderfully because of these properties, and all these properties actually in use in our system. For example, replication together with tunable consistency, it's really, really important. We enforce really strong consistency when we write data, when users subscribe, because it's important. But when we read data during push, we can say if any replica return data, it's all right. At least we deliver to really big percentage of people. And another really important properties, like streaming of results that we fetch and data compression. One of the important, really probably key properties of Cassandra that made us to choose it, it was that data, when you write on Cassandra, it's stored immutably and sequentially on a disk. Basically, when you write data for one partition K, as you see in this example, it's topic subject, everything starts to be added on a disk. And when you read millions of subscriptions, in very ideal situation, it will be just one disk seek. In reality, of course, it's not. It will be 40, maybe. Still better when you read millions from relational databases. And this is how we can store our subscriptions from previous slides in a Cassandra level. It means that this topic subject, it's a row K. It means that all data in this row will be stored sequentially on a disk. But also each entry in this row has its own key. And this will be device token. Basically, we store all subscribers for one desired event in one long row on a disk. It still has issue, but because of you still can subscribe to the team and tournament. That's all right, because we resolve this in parallel with systems that manage these subscriptions. When person subscribe to one of these, we splice this. We call this splicing when we understand that this is actually one event, and this happens before pushing. This push path thing is responsible for doing splicing. It basically understands when in this match this user subscribed to these two kind of topics. We understand it's only one, and this happens before match, and then pushboy doesn't know anything about any topic except match. It only fetches match subscribers. And it looks similar to previous, but works differently. For example, this is what makes it so beautiful and performant. Overall, Erlang runtime system, there are not that many words I can say is how beautiful it is. I don't know, this is, you can build operation system, you can do reliable software. It's just incredibly wonderful. It's my religion, I guess. But yeah, you know these properties of Erlang runtime system. You have live debugging. You can trace production systems. Very good introspection. All this goes to the first point. But of course, from new system, we can stream our subscriptions. It means that when we have already spliced subscriptions in our database, we can read this slice by slice from Cassandra, and then we start from probably not zero, but first second, push these subscriptions to these notifications to users. And using Elixir or Erlang, we can do this in parallel or concurrently. If we do this building payload, something will dispatch this, everything can go in parallel. And push gates start to be reusable. As you see, this push gate, it's completely payload agnostic. It says, these tokens should receive this binary message and deliver. And this is all what it does. And we can reuse this in any other application. And of course, more about money-wise properties. Like we have less resources to allocate, like we need Previously, it was many, like a dozen of servers with 24 cores, physical machines. Now we have maybe 8 core, 5 or so, but still it's more for redundancy than for performance, because there is no need for such performance. It's still quite good, and we focus on other optimizations. This is an example how you can achieve this with Cassandra and Cassandra driver. You basically start receiving not messages, chunks of 5,000 subscribers from database, and then you can start async processing of this. And this is oversimplified, but still close to reality thing how we handle this right now. But it still has issues, because even if you can do everything in parallel very fast, but you can't go faster than its serial part. So you still need to deal and optimize with sequential code and profile to find where it actually is slow. And we learned this through the many tryouts and other stuff, how to optimize serial code. We learned that you should avoid copying. And this is wonderful feature of DB connection library, that it passes socket on a caller level, and then you don't need to copy all the binary stuff to parse later. You parse and already have this on your caller level. And this removes pressure and memory allocation. Also, batch operations. This was interesting discovery that Cassandra has different style of batch operations. I will tell this in details on the next slide. And another interesting optimization is when you decode binary, in ideal case, you should maintain single match context and use IO list. And this last bullet point was interesting, that never do parallelization blindly, because if you say that 100 concurrent processes works better than 15, it's not true. Especially, it depends, of course, it depends what kind of processes you run. And we found that you should monitor your run queue. It means how many processes at the current moment ready to be run on a cores of your CPU, but they don't have slice of CPU. So basically you have high level of concurrency, but you waste waiting time. This is single partition batch operation. This is what helps optimize Cassandra writing. In Cassandra, each operation goes atomically, but it needs synchronization across replicas and all this communication, because when you enforce consistency. But if you use unlocked batch, and one important property of it, if you write to one partition K, in this case it's serious, it will be considered as only one single write in Cassandra, and Cassandra will communicate synchronization of this write on replicas only once. And this gives noticeable optimization. And this is real graphs what we saw after we applied this batching. So now we have splicing that even faster, and we don't miss a moment when someone probably cannot receive notification who subscribed just a couple of seconds before goal happened or something like that. And binary match context optimization. It's less known, but still very powerful and interesting optimization. There are few bullet points that show how it was applied in real projects. And in a simplified way, it's when you match binary, you continue with rest of a binary, but you should enforce some things how you do this. You always should pass the rest of the binary as a first argument, for example. And this guide at first line describes what you do. And also there is a compiler flag that says what was optimized or where you have a chance for optimization. Now it's results time. What our actually outcome after all this, what we went through. In reality, it works really nice, because previously it was 45 seconds, and this is only 45 seconds when you actually receive all tokens and you start deduplicating them, when you start actually pushing, and 40 seconds. All our competitors laugh on it. But if you do this, if you finish pushing push notifications after 15 seconds, and this is actually the time when we already know we have no more job to do. Apple knows about everything and replied, okay, I got your request. This is 15 seconds, and this is nice optimization, I think. This is what we see recently, like you have 2.5 million in 22 seconds, and yes, this is what it works right now. But we don't think that this is still good enough, because we target 2 million in 10 seconds or 1 million in 5 seconds. It's still doable, I believe, because I know some places where we do on purpose blocking call, where it could be not blocking, but then there is a trade-off, because then we lose how we can measure this, because when you're blocking, you can clearly see that this works in this amount of time. But if it's async, we lose this property. But we will find what we can optimize. For example, we still can optimize single context, matching context in HTTP2 parser. Everything looks good, but absolutely correct systems like unicorns. And saying that, I mean not that they colorful or mighty. I mean that they live in our imagination. And yeah, we saw this in practice. You should always be prepared for bad things. You should understand what's wrong and could be wrong in your system, and prepare for disaster. For example, if you use, like we using distributed queue. Distributed queue by design provide at most once guarantee, or at least once. There is no exactly once. You should choose, and we choose at least once, but then you should consider how you to do with duplicates. And either this idempotent handling, where you don't care, apply this 15 times and still all right, or deduplication manually on a level of worker. Another interesting thing we found that reordering, it's always happening in distributed systems. You can't trust events, orders that you see on a level of any component of your system. Delete can come before actual create of a subscription. So, and how you handle delete of a subscription that not yet in database. But thankfully, Cassandra treats all deletes as upserts. It's actually insert that says this was delete, and there is small trade-off. Cassandra keeps your deletes for period of time before it garbage collects it. And this is few days. So if you don't stop your system for few days between wrong order message, it's all right. And this is some limitation you should always know and understand. And monotonic time, this is the way how we resolved all our issues with writes, because Cassandra see this time, and if create will come after delete, but it has lower timestamp, you just discard it, because it's not what it's currently in Cassandra level. Thank you. That was it.
Very quick and efficient talk. We have plenty time for questions.
So can you elaborate a little on what kind of hardware you used for the actual pushing? So the limiting factor in your system, what kind of hardware are you pushing here?
You mean in the current system or previous?
In the current system. So you're saying 2 million in 20 seconds. Like how many or how much power machine-wise are you putting into that?
So I exclude database because it's not power that pushes, but one push boy, it's a single machine. We have two for redundancy mostly, and still only one starts of processing this job, and if it dies, bad luck for this notification. But this push boy, it's 8-core machine, and we still can't utilize all run queues of this machine. And this is where I say that we have many opportunities to optimize. We plan it made faster. Then when this push boy fetched all, it's fetching in streaming way and fetching. At the same time, it starts to pushing this to push gate. And we use 4 push gates, 2 for Android and 2 for iOS. And 2 for Android, it's 4-core, and for iOS, it's 8-core, mostly because HTTP2 protocol quite costly, and right now we still, as I said before, have optimization for parsing of HPAC format. So it's, I guess it's quite cheap in comparison what you need to pay if you use some paid service. And still we tried, it's don't provide any guarantees, it's slow. And this is the case, nobody won't even work with you. Even with Amazon, we ask them, maybe we can do this, but it has 2 problems. First, that we still need to manage this deduplication on our level, and they only want to store what they know. And also, another reason, they just don't want to do millions. It's a small time slice.
Hello? Oh, hello. I missed the first 2 minutes, so you may have answered it already. But hinting from the type of the subject and topics of your push notification, it seemed that a lot of the push notifications are push only, requiring no engagement from the user.
Yes.
Okay. So you have not, like, in some push notification scenarios, you want to have you have maybe a campaign, and you want to re-engage the user after a certain period of time, or depending. This is not something that you have been.
No, we still have this sub system that does non-time sensitive pushes. For example, transfer news, or we may ask question of users like, what do you think about this match, who will win, or something like this, and it's not time sensitive, and it goes on a site. It's not go through the same steps like this. We still use Cassandra, and still topics stored like this. It's streamed, but we don't closely monitor this, how it performant and everything. But yeah, we have this. And beauty of Cassandra is that in this pushes, maybe we can higher level of consistency when we read if we want. Still probably not needed, and we don't do this, but you can.
So do you to maybe concretize my question a little bit more, do you push onto Cassandra push notifications that you want to push in the future, not immediately?
Yes.
Okay.
And even if you worry maybe it will be stale data, Cassandra has time to live metadata.
Okay.
You can say this only needed for 1 week or so, and it's all right.
Okay.
There is many background Java processes that does a lot of interesting stuff, and they maintain this quite nicely.
Thanks.
Hi. Can you elaborate on monitoring? You touched that.
Yes, I wasn't sure if I will have time to add this to presentation.
Plenty of time.
Yes. Yeah, so we built this from scratch, and we wasn't sure at the beginning. You're always not sure what to do, and we didn't know what to choose. And we started again with research and evaluation, what we should choose. There is Exometer and other tools, but they quite heavy, so we didn't like ideas, and we didn't use this. We wanted something more like StatsD, but not StatsD because of format and Node.js. It's a pain to bring on each machine. And we found there is two good solutions. It's Prometheus and Influx Data company. They provide universe of tools. And we used Influx because of one requirement. And this is interesting, what makes Influx unique, that usually when you store metric under key and metric like a number. But in Influx, it's more rich format. You can store fields, and this is what we do. We store time to send push notification and extra metadata like match ID, and then we don't see overlap metrics. Because if you don't provide this metadata, it will be aggregated, and if two goals happen at the same time, you can distinguish. You could use tags, but this is high cardinality data, and time series databases after 1 million start to be pain, horrible, and slow, and fields resolve this. And yeah, we use Elixir library, small library that sends metrics by UDP to local Telegraph Go listener, and this Go listener using TCP sends to Influx storage. And we use, you can use replicas if you want to store your metrics in more redundant and safer way, if it's metrics of some important properties.
Besides metrics, you don't use any other logging, monitoring?
For metrics, we use mostly this, and we plug in places where we want. We use fprof from Erlang installation when we want to profile small places like optimization of in sequential code. And for error reporting, we use rollbar. Nothing except this, I guess.
Okay, cheers.
Thank you.
I'm going to be cheeky, so I've got two questions. Firstly, what other databases did you evaluate, and was there anyone coming close to being as suitable as Cassandra?
I was prepared for this question. Yes! Yeah, of course, I admitted this because there is actually not that much I can say because it was 1.5 years ago. Everything changed. But yeah, we tried Elasticsearch, even if it's not database. Of course, then we need some more like persistent storage. But still, we thought any database that allow us to fetch millions in any possible smaller chunk of time, then it's good for us. Then we tried Couchbase. When Memcached merged with CouchDB, it's Couchbase, I guess. But it was early stages when they just about merged, when they didn't have even NoQL language. So it's completely different right now. But it was close, but mostly because if you use servers with a lot of memory, you can put this into memory. But right now with Cassandra, we don't use any caching. This comes from a disk, and this as fast as you can have network only for now. And Elasticsearch, Couchbase, Riak. It still was different Riak 2 years ago. Yeah, these 4 we tried. Because we had limited time and research was decent. We watched what data model actually stored on a disk, what allow us all this.
Cool.
Yeah, and we actually tried actual databases, not MongoDB.
Good. For my second question, I've noticed this over a couple of the slides, and I know that you mentioned it a couple of times as well, but out of all the parts that you built, what parts ended up being open sourced?
So we didn't open source parts as of components, but we still open sourced some tools that we used. For example, this is Cassandra. If you see this on the bottom of the slide link on GitHub, it's Cassandra driver, which highly optimized with single binary matching context with streaming, which we built on top of DB connection to remove unnecessary copying. Everything that can benefit reading, we do this. And our goal to maintain this for next 5 years. I'm not saying forever. And so you can start using this. You can contribute, ask maybe features. Right now it's feature complete for us, but we want to make it 1.0 and then ask what you want, and we do this because we have high interest. I started to like Cassandra.
It's called the Stockholm Syndrome.
Yeah. And another one, it was message packs. So inside this system, through the components of the system, for example, from pushboy to pushgate, we use message pack serialization format. We can use just term to binary. It's possible, but it's not that fast. Noticeably fast, but still message packs actually as fast as binary to term if you parse because of single match context. I personally spent like week just reading assembly code of generated message packs to generate best fit. Yeah. And it's not on the slides, but we built also this library and open sourced for influx reporting. And it's doesn't care if you report to local process or you can not only use Telegraph, but report directly to InfluxDB.
Very cool. Thank you.
Thank you.
Any other questions?
Yes, so thank you for your talk. I'm wondering why you decided to write another Cassandra driver. Because there are 2, as you mentioned, and we have tried them both. We have seen the problems with them, but what are your reasons for writing a new one?
Yeah, as you said, there are issues. I don't know if there are several drivers. I know there is one Maria or something, and another it's CQRL. We used CQRL, and at the same time we was building Cassandra. But we found a lot of problems with CQRL. First of all, it was sometimes some problems when Cassandra replies in unexpected way. For example, when you have timeout on read, you have stack trace from the guts of the driver, and this is not the way we want to work with, because then we have try catch everywhere, and this is not that wonderful. Another reason, it has a lot of unnecessary copying, a lot, because processes pass this actual data from socket few times. And as I saw, parsing not optimized for single binary matching context. And in reality, if you see this pull request in message packs, single match context gave 40% optimization, and in Cassandra it was 35. It depends, of course, on the data you parse. But in our case, for 5K subscriptions we read from database, before it was 70 milliseconds to parse, because tokens quite long, everything, and now it's 40. Okay. And if you do this from millions, 5K in millions, you have many 5Ks.
Yeah, we have had the same experience with error handling in CQ. What?
CQ-Earl.
Yeah, CQ-Earl. Just a comment. We have used this Earl Cass, which is using the DataStax C++ driver, and it's hard to build. But one thing we're gaining from using that is because it is token aware, so it knows where the master of the data is. So it really speeds up our reads. So that is something that is good for a driver to have if you want to have better reads or some faster reads.
Yeah, this driver not utilize token-aware policy of load balancing yet, but it was built bearing this in mind. And right now it use simple round robin, but there is a place we need just to spend some time and implement this. But this is our goal. We want to be as fast as possible, squeeze any possible speed.
Okay, great work.
Thank you.
Any other question? All right, I think that's it. Thank you very much.
Thank you.